Welcome back to another episode of Chem 101. In this video, or in these next two videos, we are going to talk about density. And in this video specifically, I'm going to show you how we calculate density using this formula. And here are some of the units of density that we're going to be looking at. And in the next video, we're actually going to do some calculations.
Alright, in this video we're going to talk about density, basically how to calculate it, and the kind of units that we can expect to see in a density value. First thing to note for sure is that the density is simply a mass to volume ratio. That means we're going to take something's mass and we're going to put it over the volume. So density is just a ratio of a mass over a volume. So what kind of things are masses? Well, we're used to seeing units of grams, or kilograms, or even milligrams. But these are units of mass. And whenever we're talking about density, we're going to use the unit of grams when we're using our density formula. Now for volume, there are two different units that we can use that are actually equivalent to each other, and that's either milliliters or centimeters cubed. And again, these are equivalent. We can actually take this as a equality and use this as a conversion factor, milliliters into centimeters cubed. So 1 to 1. Okay, so let's take a look at calculating a volume from some kind of solid object. We could take something like a piece of wood or a piece of metal, and we would want to calculate the volume using this formula, where we would take the length times the width times the height, and so we would have to measure off what the length is. We'd want to get our height, and then also some kind of width. And with these three values, we could then calculate volume. So you can imagine a situation where maybe our actual numbers here were something like 4.0 centimeters, let's say 12.0 centimeters, and maybe something like 3.5 centimeters. So our calculated volume in an example like this would be 168 centimeters cubed. So here our volume would be in cubic centimeters. But that's not the only volume that we can have. We can have a volume that's actually a liquid and maybe not a solid object. And so in this example here, maybe we want to just use a graduated cylinder to measure the volume of this blue liquid. And it looks like if we mark that right there, this is somewhere between the 8 and 9 mark, and there's no other markings, so we would say maybe that's 8.8 milliliters. And so here you see the other unit for volume, milliliters. We can also calculate the volume of a irregularly shaped object by submersing it into water. And so let's say that we have some, odd-shaped lump of material, and we wanted to know what the volume of that was. We can record the volume of some amount of water, just like we did before. Let's say that that is 8.9 milliliters. And then we would take our solid object and we would just add it to the water. And what would happen is that the water level will actually rise. And we'll get, maybe that's not dramatic enough, we'll get a change in the volume of the water. That change in the volume of the water will actually be equal to the volume of the object that just went inside it. So to find out what the volume of the object is, we need to get the new water level, which I have drawn to be somewhere about 14.2 milliliters. So if there is now a change from 8.9 to 4.2 milliliters, then our change in volume is actually equal to 5.3 milliliters. So here we have a solid object that we had to submerge in water in order to find its volume, because the formula length times height times width really wouldn't work. And we call this volume by displacement. So now that I've shown you how to calculate volume either using a formula or using displacement, of course keeping in mind that there are other volumes formulas for volume, such as the formula for the volume of a sphere or a cylinder, not just a regular sided object like this. But let's try calculating some densities. So let's say that we have an object. Alright, so an object measures 3.3 centimeters on one side, 4.2 centimeters on the next, and 5.3 centimeters on the last side, giving us 73 centimeters cubed, if we use the proper number of sig figs. It has a mass that is equal to 28.4 grams, and so our formula for density is mass over volume. So if we plug in these values, density will equal 28.4 grams over 73 centimeters cubed equals 0.39 grams per centimeter cubed. And you have to make sure to show the units. Now let's take a look at this this unit now for a second, or I'm sorry, this value for density. We can use this as a conversion factor. Let me show you how we would do that. We can write this 0.39 grams for every 1 centimeter cubed. So let's imagine that this is the density of this object that we just measured and have the mass of. If we wanted to figure out what the mass would be, and let's say we knew something about its volume, let's say we knew that the volume was 240 centimeters cubed, and we wanted to know what the mass would be for an object of that volume, we could use the density. And in this case, we could plug it in just as it looks right there in our density formula. Centimeter cubed on bottom, so that the units cancels, 0.39 grams on top, and we would get our canceling of units and our answer in grams. And we'll calculate that in just 1 second, but we could also think about what if we knew the mass in grams. Let's say we knew that we had 18.4, let's say, kilograms, and we wanted to know what the volume would be of that material. So we would convert into grams. We'd say 1 kilogram is 1,000 grams. Now we're in the right unit to use our density. In this case, we'll have to flip it over so that the right unit is on bottom, grams. 0.39 grams, 1 centimeter cubed. And our units, kilograms cancel, our grams cancel, and we would get an answer, 93.6 grams in the volume to mass conversion, and 47,000 centimeters cubed if we use the right number of sig figs. Okay, let's calculate volume using a different method. Alright, let's see if we can understand what this problem is giving us in terms of information, and if we can calculate the density. So an object displaces 17.4 milliliters of water when it's submerged in a graduated cylinder. Right there we know our volume, because they're telling us that this object displaces 17.4 milliliters. So when we put it in water, the water level changes by that amount. So the volume is going to be equal to 17.4 milliliters. Alright, now it says that the graduated cylinder and the water weighed 54.777 grams before the object was added, and that after the object was added, the weight of everything together was 128.55. And so here is our mass information. They don't just outright tell us in this problem what the mass is, so we have to actually do a subtracting here, take the difference of these two numbers to find the mass of that object. So the object itself is 73.773 grams, and we can only keep 4 sig figs here, and keep that in mind for our density. So now density is equal to the mass, which is 73,773, divided by the volume, which was 17.4. Now, of course, our units, grams per milliliter. And so our density comes out to be 4.24 grams per mil. Okay, in the next video, we'll continue to do problems with density, using it as a conversion factor in order to not only solve for density, but to use density to solve for the mass or the volume of an object.